Yeah, I need to maximize the screen. Yes. Good afternoon, guys. Yeah, in this question is 116, and you can see the title of the question: populating next right pointers in each node. It seems not an easy question, but believe me, brother, it's actually an easy question. But the question title actually doesn't relate or complements the what we're doing, but it actually does. But it's not the intuitive title for this question. Yeah, but I'll show you. But yeah, let's first understand the problem what they gave us. You're given a perfect binary tree. Remember that perfect binary tree where all leaves are on the same level. It means the every last node of the tree are on the same level. There is no chance that you will get a node on as a in a separate level. A single node, independent node is there. That's not the case. They don't give that kind of binary tree. They'll just give every last node in the tree ends in the same level. That's what they guarantee. They are saying perfect binary tree. That's what it actually means. And every parent has two children, and the binary tree the following definition. Yes, what the binary tree that they are giving actually the value of a node, left and right pointers, and here comes the new stuff. New brother is nothing but next. This is what we need to do. We need to actually connect this one. Right, I'll explain you. Populate each next pointer to point it to its next right node. If there is no next right node, the next pointer should be set to null. But that doesn't be because that is a perfect binary. If this is the case, yes, this will actually present because at some cases that should be null. The the right pointer is going to be null. Yes. So initially all the next pointers are set to null. Yes, that's true. Initially there is no listen. The properties of the binary tree here are node dot value, which is 1, node dot left, which is 2, node dot right, which is 3, node dot right, sorry, node dot next. There isn't nothing kind of that thing. The next is nothing but the connection between its left and right children. It means 2 dot, sorry, root. In this case consider root as 1, so root dot left dot next is actually 3 in this case. So that is what they want. They want to make connections between the two childrens that they have. And also we need to make these childrens also because this grandfather wants everyone to be connected internally. So every left node should connect to its right node. That's what they want. That is being, that's the reason they have mentioned next right pointers. So we need to point to the right. And yeah, you do understand. Yeah, let me explain the approach how we gonna do this here. Yeah, you can see that the next pointer is always connected to the right. So this is a perfect binary tree. So we can say that we can directly connect to its right pointers by just doing root dot left dot next equals to 3, right? Is my pointer. Yeah, what I'm saying is root dot left, root dot left dot next equals to, what is that? Root left dot is equal to root dot right. So I'm just saying that if you see here root dot left dot next means root dot left dot next equals to root dot right, means we are making connection here. Yeah, we are done with the connection. Yeah, that's perfect. So then what we gonna do? You need to check. In this case this is a root node, but if you go into the tree, then this is a node and this should be connected to this one, and we need to connect these both. So to connect these both, this connection should be established. That's what we are doing. But there is a case that there is no connection. So for to ensure that one, root dot, we need to handle a case there is a chance of not being connecting, right? So if we have a condition case, if root dot next value is not equals to null, it means what? It means there is a next pointer. It means root dot. Assume that when we came here, what is root dot next? It is nothing but 3. Root dot next value is not equals to null. That's true. Then what we can do, we can connect this part. What I actually told, this connection is there now between 5 to 6. We can connect these nodes. So for this case, this condition actually allows us to connect these 5 and 6 nodes. So that is the reason we are checking for safe side using the condition. We're actually connecting the next right pointer to 5 to 6. So nothing we can do now, we can just do root dot right dot next, root dot right, root dot right dot next should point what? Tell me guys. It's nothing but root dot next dot left. Sorry, what am I doing? It's next, root dot next dot. Yeah, this makes our work easier. And yeah, this is the condition that we want to do, and we've done that one. And then we'll move to, we'll do the call what is this? Is this a conversion? No, something like connect. Yeah, this is the function that we have. Holy shit, connect. We need to pass the pointers. There's nothing but root dot left. And then in the next call, we need to do root dot right. Root dot left, and you again need to call one more time. There you're gonna do same thing, but root dot right. Yeah, these are the cases that we need to do, and also I forgot to show you the base case that we need to keep. The base case is nothing but if root value is equals to null, or root dot left value is equals to null, then what does it actually mean? Tell me. Root dot left value is equals to null means when this is root and there is no node here, assume that this is null now, and root dot left value is equals to null, then we need to actually return, brother. We don't need to do anything, we just need to return here, and yeah, we are done. That kind of thing. So let me show you the code and be more helpful and be more understandable for you to view in a bigger picture. Yeah, so let's do the same way how we done that. Yeah, I'll show you the code. I'll paste the code. Just pasting that is perfectly enough, right? Holy shit. Why this motherfucker is moving this slow? Yeah, we got it. Yeah, first we're just checking root dot left value equals null, then return root. Yeah, then root dot left equals root dot left dot next equals root dot right. It means we're actually correct. I'm directly showing you that you can understand a more intuitively. Root dot left dot next equals to root dot right. It means 2 3 have been connected, and then what we'll do is if root dot next value is not equals to null, is that true? Root dot next root is actually 1. Root dot next value is there, is it not null? No, it's actually null. So we won't enter the if condition. Then what we'll do, connect equals to root dot left. So we'll go and make a root as 2. And now for this case, this is a root, and we'll do root dot left dot next equals to root dot right. So these are actually being connected and not this one. Let me erase you. Yeah, this isn't the connection. That's a previous connection that I made. I need to erase that because we are actually moving freshly, and we have been connected this one, and we need to check that if root dot next value is not equal to null. Is that true? Is that true? Root dot next value is not equal to null. Is that true? Yes, that is not equal to null because it's actually 3. We are being connected and it is not null. Then what we can do? We can guarantee that if these two are connected and it is a perfect binary tree, everyone has same levels and we are calling our child, and we can also call their child and we can connect, right? So what we can do is if root dot next value is not equal to null, then root dot right dot next equals to root dot next dot left. It means we are connecting this way. And then what we need to do, what is the other case? There's no other case. Then we'll complete that line and then we'll recursively call root dot left and it will return root. It will return back here. Yeah, we'll call root dot left, and then we'll return root. If root dot left, sorry, here actually we completed 2 as a root, and what we are saying is if root dot left value is not equals to, sorry, we actually move root dot right, and here if root dot left dot next value is equals to null, then we need to return this root. Whom you gonna return this? 4. You gonna return to your parent, and he says that root dot right. And when we are at here, we'll do same thing. We'll return him, and we'll go here, and we are at here, and our right pointer and our current node is actually 3. And what we'll do is root dot left dot next equals to root dot right. Then we will connect this one, and then we'll go, you will move a pointer, your current pointer is actually this one 6, and root dot left value is actually null. You will return to him and he will call root dot right, and root dot right dot left value for, and when this is the case where root dot left value is equals to null, and we'll return null. Then we'll return to root, and that's it. If you see there, we have actually been connected all the nodes, and that's the conclusion that I want to make sure that we have finally connected. Yeah, that's it. Thank you.